Let's see the properties of a very important property. Determinant problems, most of the problems are going to be based upon these properties. Okay, let's see those properties. Right, very important. You have to learn these properties carefully. Okay, first one, that is always the determinant of upper triangular matrix, lower triangular matrix, or a diagonal matrix or scalar matrix is always simply the products of principal diagonal elements. If the matrix is diagonal or scalar or upper triangular or lower triangular, always simply will say the determinant simply by multiplying the principal diagonal elements you will get a determinant. By adding the principal diagonal elements you will get trace, but for any square matrix, but not any square here, particularly for some matrices, that is upper and lower and diagonal and scalar. Just we will see an example here. See how that is if 1 2 3 0 4 5 0 0 6, if you want to find a determinant for this matrix, this is what simply what this is what upper triangular matrix. The elements below the principal diagonal elements are equal to 0. That's why this is upper triangular element. Already we said simply principal diagonal elements కంటే కింద ఉన్న ఎలిమెంట్స్ లేవు, పైన ఉన్నాయి బట్ ఇండైరెక్ట్లీ చచ్చిపోయిన వీటి గురించి మాట్లాడదు, బతుకున్నాయి, దట్ ఈస్ అప్పర్ ట్రయాంగులర్ ఎలిమెంట్స్ ఉన్నాయి, but matrix is upper triangular matrix. Simply what we are saying, the determinant is 1 into 4 into 6. If you find 6 4 the 24, you will get answer directly. If you follow the procedure, already we know the shortcut, that is 3 into 0 into 0, 1 into 4 into 6, 2 into 5 into 0. 0 వచ్చినాయి, 2 values, only 1 value ఉంది. ఇప్పుడు if you take from here 6 into 0 into 2 0, 0 into 4 into 3 0, 0 into 5 into 1 0, or simply if you expand by using row number 1, that is 1 into plus 1 into determinant, that is 4 5 0 6. Next second, or if I use by using column number 1 determinant, 1 into this matrix, next minus 0 into something 0, next plus indirectly this element 0 into something 0, only this value, that is 1 into 4 into 6, you will get answer. Or one more example I am giving here. For suppose the matrix is 5 0 0 0 5 0 0 0 5. This is what scalar matrix. Simply 5 cube is your answer. Simply the product of principal diagonal elements. Very important property. So many times based upon this you asked the question. He won't give this property, but he will give like this the problems. If always the matrix is upper triangular or lower triangular or diagonal or scalar, always simply the determinant simply product of principal diagonal element. Sometimes we'll convert the matrix into upper or lower triangular to get easily the determinant of that matrix. Here see one more property very important, that is very important. If two rows or two columns are identical and proportional, you will see in both cases here identical or proportional, then determinant is always 0. See if two rows or two columns we are saying in a matrix, for suppose I am taking an example, that is A1 B1 C1, or simply we will take elements, you will get understand very easily, right? We'll see, that is for suppose I am having a matrix 1 2 1 4 5 6 1 2 1. Here see in this matrix, this is row number 1, this is row number 3. Here 1 to 1 is there, 1 to 1 is there, that is the meaning of identical. Identical means same values, same numbers. If two rows, for suppose 2 1 2, it is different, but 1 to 1 ikkade element undo akada same elements, row mottam as it is ga a row gavachu leda either columns gavachu. If two rows or two columns, here one row and another row, that is two rows are identical, that's why if you find the determinant also you will get 0. If you want, you can check that by using our shortcut. right? And proportional is saying indirectly proportional means in physics you are going to get so many times, that is proportional means if input is proportional to output, if inverse proportional ante input proportional unte input change aithe output kuda same change exist aitadi, increase aithe increase, decrease aithe decrease, same thing here. For suppose I am having like this matrix, for suppose like this 2 4 2. Here just I represented rows, just I am representing your columns. Here column number 1 and column number 3 both are proportional, that is 1 to 1. If you multiply this column number 1 with 2, you will get 2 4 2. That's meaning of proportional. If like this are also existed, the determinant always is going to be 0. That these two statements very important. That is what the determinant of upper and lower and scalar and diagonal always is the product of principal diagonal elements, and if two rows or two columns are identical or proportional, the determinant is equal to 0. Okay, let's see more properties also here. Okay, based upon we will give an examples for properties better and to better understand. Okay, let's see other properties also. Yeah, these are the properties, other properties. See, if I interchange two rows or two columns of a matrix, any two rows in place of one row in the other row or other row place lo inko row replace cheste, simply the determinant simply multiplied with -1. అంటే ఇంటర్చేంజ్ చేసినప్పుడు డిటర్మినెంట్ అనేది కంపల్సరీ చేంజ్ అవుతుంది, చేంజ్ అనేది జరుగుతుంది. దట్ చేంజ్ ఈజ్ సింప్లీ మల్టిప్లైడ్ విత్ -1 you will get. For suppose I am writing one example here. I am writing elements a1 b1 c1. Here I am writing a2 b2 and c2, a3 b3 c3. This is the determinant. నేను ఏం చేస్తాను అంటే this is column 1, this is column 3, this is column 1, this is column 3. ఇంటర్చేంజ్ చేస్తాను నేను. In place of column 1 I am writing column 3, in place of column 3 I am writing column 1, that is a3 b3 c3, and a2 b2 c2 అట్లనే ఉంది a1 b1 c1. Simply interchange చేసినాం. That indirectly that is going to be multiplied with minus. -1 is nothing but minus. For suppose if the answer of the determinant is -88, this determinant is going to be +88. If you multiply with minus, it's going to be satisfied. ఇంటర్చేంజ్ చేసినప్పుడు అంటే ఇంటర్చేంజ్ మైనస్ లేకుండా ఇంటర్చేంజ్ చేసినాము అంటే ఇండైరెక్ట్లీ ఇఫ్ ఇట్ ఈస్ మైనస్ దెన్ ఇట్ ఈస్ గోయింగ్ టు బి ఈక్వల్, ఇఫ్ ఇట్ ఈస్ నాట్ మైనస్ ఇట్స్ నాట్ గోయింగ్ టు బి ఈక్వల్. ఇఫ్ యూ వాంట్ యూ కెన్ చేయక ఇఫ్ యూ టేక్ సింప్లీ వన్ మ్యాట్రిక్స్ అండ్ ఫైండ్ ద డిటర్మినెంట్ అండ్ సింప్లీ ఇంటర్చేంజ్ దట్ row or column, then you find determinant, then you will get an answer. Simply that is by using this property. Simply if you interchange two rows or two columns, then determinant is multiplied with -1. If I interchange two rows or two columns 2 times, then you will get plus, 3 times you will get minus, like that. Okay, this is also asked in ECET as a statement, right? One more property that is very very important. By using this property only, by using these properties only, we are going to do so many problems as such. That is if a non-zero constant is multiplied with row or column of elements or added with another row or column, then determinant is unaltered. Unaltered is nothing but does not changes. అంటే ఇండైరెక్ట్లీ ఇలా చేయడం వల్ల డిటర్మినెంట్ అనేది చేంజ్ కాదంటే ఎలా? ఇండైరెక్ట్లీ ఏ నాన్ జీరో కాన్స్టెంట్, జస్ట్ ఐఎమ్ టేకింగ్ వన్ రో, ఐఎమ్ రిప్రజెంటింగ్ విత్ ri, a non-zero constant I am taking k multiplied with row or column are added with another row or column, just I am taking rj. Here k not equal to 0 to represent that I am taking here non-zero. And whatever the value if you write here indirectly in place of that, indirectly some not equal to 0, 2 into r1 plus r3, then before this matrix, after doing like this, the determinants are going to be, both are going to be equal, does not changes is saying. For suppose if it is 0, non-zero అని చెప్పుకుంటున్నాం. For suppose if it is 0, indirectly ri tends towards indirectly interchange అవుతుంది. ఇంటర్చేంజ్ అయితే డిటర్మినెంట్ అనేది చేంజ్ అవుతుంది. ఇంటర్చేంజ్ కావద్దు అంటే ఖచ్చితంగా నాన్ జీరో కాన్స్టెంట్ ఉండాలి. నాన్ జీరో కాన్స్టెంట్ ఎగ్జిస్ట్ అయినప్పుడు కంపల్సరీ డిటర్మినెంట్ అనేది చేంజ్ కాదు. దట్స్ వీటిని ఏమంటారు అంటే ఎలిమెంటరీ రో ఆర్ కాలమ్ ఆపరేషన్స్. ఎలిమెంటరీ రో ఆర్ కాలమ్ ఆపరేషన్, ఎలిమెంట్స్ మీద ఆపరేషన్ అప్లై చేస్తాను, ఇండైరెక్ట్లీ చేంజెస్ చేస్తాను కాబట్టి రో ఆర్ కాలమ్ ఆపరేషన్స్. టోటల్ రో ఎంటైర్ కాలమ్ చేంజ్ చేస్తున్నాం. వై? బికాజ్ ఇండైరెక్ట్లీ ప్రపోర్షనాలిటీ బేస్ చేసుకొని చేంజ్ అయినప్పుడు బేస్ చేసుకునే పాయింట్ ఆఫ్ వ్యూ ఇండైరెక్ట్లీ ఈ రో ఆర్ కాలమ్ని ఇంటర్చేంజ్ ఇండైరెక్ట్లీ ఎలిమెంటరీ ట్రాన్స్ఫర్మేషన్స్ అప్లై చేస్తే డిటర్మినెంట్ అనేది చేంజ్ కాదు కాబట్టి ఇలా అప్లై చేసి సింప్లిఫై చేసి మనం ఆన్సర్స్ అనేవి ఈజీగా మనం ఫైండ్ అవుట్ చేయొచ్చు. అంటే ఇది అప్లై చేసినాక కంటే ముందున్న మ్యాట్రిక్స్ డిటర్మినెంట్ అనేది అప్లై చేసినాక మనకి ఈజీగా అడ్జస్ట్ అవుతున్న మ్యాట్రిక్స్, రెండు మ్యాట్రిక్స్ డిటర్మినెంట్ అనేది ఈక్వల్. ఈజ్ ద ప్రాపర్టీ ఈజ్ దట్స్ వై వీఆర్ గెట్టింగ్ సమ్ డిఫికల్టీ ప్రాబ్లమ్స్ as very easily, right? These are the properties very important. So more properties also we have to see, right? Let's see other properties also here. Let's see these properties are here. These are also very important properties. That is a determinant of A transpose equals to determinant of A. That is for suppose if I am having like this matrix, that is the determinant of 1 2 3 4 5 6 and 8 7 8 9. If I interchange rows as a columns, that is A transpose we are doing. That is if I write like this 1 2 3 4 5 6 7 8 9. If you find determinant for this one also, you will get same answers. Determinant of A transpose after transposing the matrix also, if you know the determinant of A, we can say directly. For suppose if you know the determinant matrix, if you know one matrix determinant, if you asking what is the determinant of A transpose, simply if you know determinant, that based upon that you can say answer. And AB is one matrix and A is other matrix and B is other matrix. By multiplying A and B you will get AB. But if you know determinant of A, determinant of B, we can say determinant of AB directly. Determinant of A is nothing but determinant of A into determinant of B. And a very important property, that is here determinant of Ka equal to K power n into determinant of A. For suppose just I am given an example, that is if A is a 3/3 matrix, then determinant of A equal to 5, then determinant of 4A equals to what? If you are asking like this question, we know determinant of A, we can say determinant of K directly. That is 4A determinant equal to 4 power n equal to 3 into determinant of A. That simply 4 power 3 into 5, that is going to be our answer. 4 4 the 16, 64 the 64, 64 into 5, what? 320. Yes, like this we can say the answer, right? If A, determinant of A if you know, and order also, without order also, if we define A matrix also, if you asking for A, by multiplying each and every element for, it will take more big problem, and multiplying also it will take more time. Simply by finding determinant of A, we can say determinant of K. How you are getting, we'll see. Just I am taking an example to explain the determinant indirectly this matrix. For suppose if I am having A equal to 1 2 3 4. Now from here, what is determinant of A arrow? That is 4 minus 6. 4 minus 6, that is AD minus BC. 4 minus 6, that is nothing but minus 2. For suppose I am having one more B. B is nothing but 2 4 6 8. Now from here, what is determinant of B here? 16 minus 6 for the 24. That is going to be your answer. What? Minus 8. Let's see here, this is B, this is A. We having the relation between A and B. We can write B equal to 2A. Finding determinant B is nothing but determinant of 2A. From here, determinant of 2A is what? This is of order 2 by 2. That's why 2 square into determinant of A. 2 square is nothing but 4 into minus 2 is nothing but minus 8. You got or not? You got or not? Any value. Like here see in determinant by using this concept. For suppose if I write like this, here whenever if you are having like this, for suppose here in determinant here we are having 2, 4, 6, 8. I can write this matrix as a, that is indirectly 2 square into determinant of 1, 2, 3, 4. That is 2 square is nothing but this one. And also I am writing this one as directly. I can take from any row, from any column we can take, if possibility is there, we can take common things. For suppose from row, actually taking common in a matrix means each and every element, from every element will take in determinant each and every row or each and every column we have to take. For suppose you are taking common means only one row. Here see from one row, first row I am taking 2 outside, that is 2 into, we can write 1, 2. 1, 2, here same element 6, 8. If you find, you will get same answer, that is 8 minus 12. 8 minus 12 is nothing but minus 4 into 2 minus 8. And also we can write this one as 2 into 2, 4, 3, 4. If you take here also 2 common, and just I taken here from here 2, you got this one. If I take here 2, you got this one. If you take from here to here 2, you will get A2 square. 2 into 2. Means determinant లో కామన్ తీయడం అనేది, కామన్ తీసే ప్రొసీజర్ అనేది ఏదో ఒక రో కావచ్చు, ఏదో ఒక కాలం కావచ్చు. ఫర్ సపోజ్ ఇఫ్ ఐ హావింగ్ లైక్ దిస్ మ్యాట్రిక్స్, ఫర్ సపోజ్ డిటర్మినెంట్ ఆఫ్ 3, 6, 2, 4. From here you can take 3 common. That is going to be 1, 2, 2, 4. Here already we taken 3. From this also we can take 2 common. That is 1, 2, 1, 2. This is going to be 0, but common I am checking. I am saying just common things. Okay, sometimes if you are not getting also here 3, 4 is there. From here you got 3, but we didn't got anything here. No problem. If you find answer, you will get answer. That is whatever the answer is there. 12 minus 3, 6, 18. 12 minus 18 is nothing but minus 4. You will get here same thing. 4 minus, you will get. Understanding my point? Nothing is there. Simply in determinant, Ka is there, K power n into determinant we will write. Or if you are taking any value common, you are going to take like that. Indirectly, ఏదో ఒక రో, ఏదో ఒక కాలం నుంచి వెళ్ళి కామన్ అనేది తీయాలి. Understanding my point? Understanding my point? Simply, these are the very important properties, and one more property is there. We will discuss that. That is also with some examples. Let's see that property. Let's see other properties. That is the determinant of Q-symmetric matrix of odd order is always 0. What is saying? The determinant of Q-symmetric matrix of odd order. Actually, our matrices, in our matrices up to 3 by 3 only we got. That is 2 by 2, 3 by 3 we are learning. 2 by 2 is even order. 3 by 3 is nothing but odd order. 4 by 4 even. 5 by 5 odd order. but he is giving generally, that is determinant of any odd order q symmetric matrix always is going to be 0. If you want, you can check. Here I am writing one example here, that is a 0 p q minus p 0 r minus q minus r 0. He asked this as a ECET question. See here, this is a simply always the principal diagonal elements are zeros, remaining elements are in additive inverse. This is p, this is minus p, this is q minus q, r minus r. Q symmetric matrix, that too odd order 3 by 3. If you find also, you are going to get 0. That is, if you find here, see first element q into minus p into r, minus into minus plus na p q r, next 0 into 0 into 0 plus 0, next p into r into minus q minus p q r minus of, next 0 into minus p into p minus p square, minus 0 into minus p is nothing but 0, next minus q into 0 into q plus 0, minus r into 0 0 plus pq minus pq. Simply what answer is going to be 0. RC I am saying by using this one only. For suppose if I take order is n, what is saying determinant of q symmetric matrix. Actually q symmetric matrix is nothing but A transpose equals to minus A. I am taking both side determinant of A transpose equal to determinant of minus A. Previously we said always determinant of A transpose equal to determinant of A only from the property, previous property. Here we can write in place of determinant of A transpose, we can write determinant of A is nothing but here see determinant of minus A is nothing but minus 1 into A. Determinant of Ka equals to what? K power n into determinant of A. Here k equal to minus 1 to the power of n into determinant of A. Now see, n is what? Odd. Minus 1 to the power of odd number always is going to be minus determinant of A. Determinant of A equal to minus determinant. If we take this side, it's going to be plus, that is 2 determinant of A equal to 0. From here simply determinant of A equal to 0. This is the proof. Either if you like remember like this also no problem, if you if you remember like this also no problem. Simply the question is going to be like this, not like statement. The determinant of q symmetric matrix of odd order is, what is the odd order? You won't ask, you will ask like this. Simply if we are asking like that also, the determinant of q symmetric matrix of odd order, we can say that answer, that is simply 0. See one more property, that is the determinant of orthogonal matrix is, if you learn this as a problem, it's very good. See, already I given what is orthogonal matrix. That is A into A transpose equals to A transpose into A equals to identity matrix. Then the matrix is said to be orthogonal matrix. This is the condition for orthogonal matrix. Based upon this condition, A into A transpose equals to identity matrix I am taking. From here, determinant of A into A transpose equals to determinant of I. From here, always we said determinant of AB, whatever just previously I said, I am using here determinant of AB equal to determinant of A into determinant of B, we can write here A and B are, A is A and B is going to be A transpose. If you write here determinant of A into determinant of A transpose equal to determinant of I, identity matrix, diagonal matrix determinant is simply product of principal diagonal elements. Indirectly that is going to be 1 only. Identity matrix determinant, if you remember this one also very good, that is determinant of identity matrix of any order always is going to be 1. Same thing here A transpose is nothing but determinant of A. From here we can write determinant of A into determinant of A equal to 1. that indirectly determinant of a square equals to 1. Indirectly here we want only determinant of orthogonal matrix. Determinant of orthogonal matrix, indirectly A is orthogonal matrix, determinant of A is nothing but plus or minus 1. For suppose plus 1 is there, it's no problem. Minus 1 is there, it is going to be answer. If plus or minus 1 is there, always you have to write only plus or minus 1. This is also asked in ECET so many times. Last year question, and in other competitive exams also in matrices you got this question. Very very important. This is also asked. You have to remember this all properties. Whatever the properties I said, that you have to remember those. Once I am revising indirectly. First property is what? The determinant of upper triangular matrix and lower triangular matrix and diagonal matrix and scalar matrix is a product of principal diagonal elements. ఈ ఏ టైప్లో వచ్చిన మ్యాట్రిక్స్ ఏ టైప్లో వచ్చిన సింపుల్గా ప్రిన్సిపల్ డయాగనల్ ఎలిమెంట్స్ని మల్టిప్లై చేస్తే డిటర్మినెంట్ అనేది వస్తుంది. వన్ మోర్, ఇఫ్ ఐ ఇంటర్చేంజ్ 2 rows or 2 columns of a matrix, then determinant that is not interchanging, that is if 2 rows or 2 columns of a matrix are identical or proportional, then determinant is 0. If I interchange 2 rows or 2 columns of a matrix, then the matrix is multiplied with -1. The 2 rows 2 columns ఐడియల్గా ఉన్నా అంటే సేమ్ ఉన్నా ప్రపోర్షనల్గా ఉన్నా డిటర్మినెంట్ అనేది సింపుల్గా 0. ఒకవేళ 2 rows-ని ఇంటర్చేంజ్ చేస్తే లేదా 2 columns-ని ఇంటర్చేంజ్ చేస్తే డిటర్మినెంట్ అనేది మైనస్తో మల్టిప్లై అవుతుంది. అండ్ వన్ మోర్ వెరీ ఇంపార్టెంట్ ప్రాపర్టీ బేస్డ్ అపాన్ దట్ వీఆర్ గోయింగ్ టు లర్న్ అని చెప్పుకున్నాము. దట్ ఈస్ వాట్ ఏ నాన్ జీరో కాన్స్టెంట్ ఈజ్ మల్టిప్లైడ్ విత్ రో ఆర్ కాలమ్ ఆఫ్ ఎలిమెంట్స్ ఆర్ అర్డ్ విత్ అనదర్ రో ఆర్ కాలమ్, then determinant is unaltered, does not changes అని చెప్పుకున్నాం. దట్స్ we given elementary transformations అని to remember that I given ri tends to k into ri plus rj, అంటే ఏదో ఒక రో ఎలిమెంట్స్ని కాన్స్టెంట్తో మల్టిప్లై చేసి ఇంకో రోతోని ఎలిమెంట్స్తో యాడ్ చేస్తే డిటర్మినెంట్ అనేది చేంజ్ కాకుండా ఉంటుంది. ఇది ప్రాపర్టీ బేస్ చేసుకునే ప్రాబ్లమ్స్, డిఫికల్టీ ప్రాబ్లమ్స్ ఆన్సర్ చేస్తాము. అండ్ యూ హ్యావ్ టు రిమెంబర్ దీస్ ఆర్ ఆల్ డిటర్మినెంట్ ఆఫ్ ఏ ట్రాన్స్పోజ్ ఈక్వల్ టు డిటర్మినెంట్ ఆఫ్ ఏ, డిటర్మినెంట్ ఆఫ్ ఏబి ఈక్వల్ టు డిటర్మినెంట్ ఆఫ్ ఏ ఇంటూ డిటర్మినెంట్ ఆఫ్ బి, డిటర్మినెంట్ ఆఫ్ కేఏ ఈక్వల్ టు k power n into determinant of a. And if you remember that also very good. And here always the determinant of symmetric matrix of odd order always is going to be 0, and orthogonal matrix determinant always is going to be plus or minus 1. If you have to remember this one indirectly, this is asked in ECET 2016 lo ochindi, 2018 lo ochindi, so many times asked. If you remember, if keep in a box, then you are going to learn. ఓకే, ఈచ్ అండ్ వన్స్ అగైన్ ఐఎమ్ సేయింగ్ కంపల్సరీ మీరు నోట్స్ మెయింటైన్ చేసుకుంటూ ఈచ్ అండ్ ఎవ్రీ టైం నోట్స్ కంపల్సరీ క్లాస్తో పాటు వీడియో లెక్చర్తో పాటు నోట్స్ అనేది సేమ్ యాజ్ ఇట్ ఈజ్గా ప్రిపేర్ చేసుకోవాలి. ప్రిపేర్ చేసుకుంటే ఇట్స్ గోయింగ్ టు బి రిమెంబర్ ఫర్ యూ పీపుల్ యాజ్ వెల్ యాజ్ ఇండైరెక్ట్లీ వినడంతో పాటు రాయడంతో ఈజీగా మీకు గుర్తుండిపోయే అవకాశాలు ఎక్కువ ఉంటాయి. రైట్, లెట్స్ డిస్కస్ సమ్ ప్రాబ్లమ్ బేస్డ్ అపాన్ దీస్ ఆల్ ప్రాపర్టీస్. లెట్స్ సీ సమ్ ప్రాబ్లమ్స్. ఓకే,